Hi, folks. Welcome back to 8.5 and 8.6 parametric equations. And so in this video, we're going to take a look at one last example about graphing parametric equations, but then we're going to use that to ease into the idea of eliminating parameters. Okay. All right. So sketch the curve for x of t equals 5 cosine t and y of t equals 5 sine t, all right? So we're going to put all our y values in this column. We're going to put all our x values in this column, and we're going to use it as a way to refresh our trig values, okay? Now, because we're going to be plotting these points over here in whatever shape this might be, right? Because we're going to be plotting these points, we're going to go ahead and use a calculator. And I'm going to say let's round to like 3 decimal places and kind of see where that gets us, right? But if we put in 0, we should get 5 for x and 0 for y. If we put in pi over 6, we should get 4.3 for x and 2.5 for y. If we plug in pi over 3, we should get 2.5 and 4.3. And if we plug in pi over 2, we should get 0, 5. Okay. Now I'm going to stop here and I'm going to say, let's start plotting some points that we have so far and see if we can start to see what's happening. Okay. So the very first point I'm drawing is 5, 0. That's going to be right over here. Okay. And then I'm going 4.33 and 2.5. So maybe somewhere here. And then I'm going 2.5, 4.33. And then I'm going to 0, 5. Now I'm starting to see a shape. And so far, I've only used a quarter of this table, okay? So I wonder, where have we seen sine and cosine a lot before, right? And it is none other than the unit circle, okay? So if we plot some other values, 2 pi over 3, 5 pi over 6, and pi, all right? We end up with the cosine values becoming negative and the sine values staying positive but going back down, okay? And if we continue to plot those, let's see what we get. Right? And lo and behold, we start to see that we indeed have sort of the top half of a circle, okay? And so I'm not going to make us go ahead and plug in all the other values, but let's go ahead and start to draw this circle. Well, let's try that again. All right. And lo and behold, if we were to plot everything exactly the way that it is, we would end up with a circle with a radius of 5. Okay. Now that's not a coincidence. But let's go ahead and mark our direction before we go any further, okay? So we started here and we went in this direction, okay? So keep in mind when we're graphing, we do have to put those arrowheads down. Otherwise, it's not a full credit graph, right? We have to show that we know there's a direction, and so we have to include those arrowheads, all right? But this is one way of doing it. And as you can see, this kind of requires a calculator to do. We got to plug in all of these numbers. And it's like, I didn't even plot all of them. I only plotted half of the circle. It's just kind of a lot, right? So that's where this technique called eliminate the parameters comes in helpful, all right? Eliminate the parameters basically means we're going to take our x equation and our y equation, and we're going to go ahead and get rid of the t's, okay? So I'm going to show you one way to do it that I don't want to see. In fact, I don't want you to do this so much that I'm going to put it in red. Okay, so do not do this. Let's say I solve for t here. So option 1. If I solve for t here, I'm going to get x over 5 equals cosine t. And then I actually get that t equals the inverse cosine of x over 5. Okay. Now, there is nothing mathematically wrong with what we're doing so far. Everything we're doing is mathematically accurate. But now, if I take this t and I plug it into the y equation, I'm going to get y equals 5 sine of inverse cosine of x over 5. This looks gross. In fact, this looks like one of the test questions on the last test that a lot of us got wrong, right? It's not something that's very natural for us. Do not do this, okay? If you have some friends who choose not to watch the video and then do it this way, I don't really feel badly for you. We're not doing this method because it's not something that really helps us say, oh, 5 sine inverse cosine of x over 5, that's a circle with a radius 5, right? That's not natural for us. But I claim that we can actually take this, eliminate the parameters, meaning get rid of the t's in another way, so that we can actually tell what shape this is. And this is actually going to help prepare us for chapter 10, right? So pay attention because the work we're putting in here is actually going to be helpful for chapter 10. All right. So I'm going to say, let's take our equations and we're going to solve for cosine t and sine t. All right. So we're going to do part of this. So cosine t is x over 5. And sine t, I'm just going to divide both sides by 5. I get y over 5. Okay. So I've got my cosine and my sine equations. And now, connection to chapter 7. Remember back when we said sine squared theta plus cosine squared theta equals 1? Yeah, and that came from the Pythagorean identity, but just for unit circle, right? Well, it turns out if I change my thetas to t's, it's still true, okay? And we might remember that sine squared is really sine t squared, and cosine squared t is really cosine t squared equals 1. And now check out what we're going to do. Everywhere we see a cosine t, we're going to put x over 5. And everywhere we see a sine t, we're going to put y over 5. Okay, so I'm going to have y over 5 squared plus x over 5 squared equals 1. And we're going to rewrite this a little bit more. Y squared over 25 plus x squared over 25 equals 1. We're going to do one last thing here. We're going to multiply the entire equation by 25. Now, spoiler alert, in the next chapter, in chapter 5, we're going to learn that if I have something of the form x squared plus y squared equals a number squared, that we actually have a circle with a radius that is the square root of this number. X squared plus y squared equals 5 squared. That means we have that means we have a circle with radius 5, which is exactly what we had when we did the graph, right? We have a circle with a radius 5. So don't do this because who knows what that looks like. Do this because it gets us really close to one of the forms of the equations that are nice to know, right? Like a circle. All right, so that was a long example, but let's go ahead and practice that with a couple more examples, just eliminating the parameter part, okay? So we've got our x equation, and we've got our y equation, okay? And we've got our x equation and y equation. And I want to get rid of the t's. Like, I want to get the equation so that there's no more t's. There's only x's and y's, okay? And so here's what I'm going to do. I'm going to grab the x equation, and I'm going to go ahead and solve for t squared, all right? So x plus 2 equals t squared. Now, I could take the square root here. I could say t equals the square root of x plus 2. But I'm not going to do that. And here's why. I notice that the other equation already has a t squared. That means everywhere I see a t squared, I can put x plus 2. No need for square root. Y equals 1 plus 2. Instead of t squared, I'm going to put x plus 2. All right. I'm going to do a little simplifying here. Let's see what happens. Y equals 1 plus 2x plus 4. And I'm going to combine some like terms. Y equals 2x plus 5. Okay. Oh my goodness. Are we saying that this complicated looking set of equations, these parametric equations, is secretly telling us we have a line? We are, in fact, okay? One thing you might notice, this has a square and this has a square. When the t's have the same degree, we're always going to get some kind of line, all right? That's why on exam 1, I was like, we got to remember how to do our y equals mx plus b, because that helps us recognize the shape of the graph we have, and we can plot that pretty quickly, okay? All right. Now, here's our equation. We have eliminated the parameter. So we have done step 1, okay? Now, I'm going to leave this part up to you. So, if you would like some extra credit, all right, you're going to go ahead and figure out what the graph of that looks like, including the directions and where it stops and starts, and come on Zoom and explain that to me. Okay, so what does that graph look like? Come on and explain that to me for extra credit. Okay, all right. One last example here on eliminating the parameters using substitution. We've got our y equation. We've got our x equation. All right, so x and y. And we want to get rid of one of the t's, okay? So I'm going to start with the x equation, because if I take this equation and I square both sides, the square root goes away, okay? And if I get 2t all by itself, I can plug that into the green equation everywhere I see a 2t, okay? So 2t equals x squared minus 4. That means in the y equation, instead of 2t plus 1, I can write x squared minus 4 plus 1. Or really, y equals x squared minus 3, right? No more t's means that I have eliminated the parameter. Totally fine. Okay, Same thing here. If you'd like to come to extra or to office hours or make an appointment and explain to me what this graph looks like, including all the directions and how you got that, you be my guest. Okay. So we've got both questions on one page here for you. Extra credit is in the graphing, but we've really started to take a look at what it means to eliminate the parameter. In the third and final video, we're going to work mostly on the algebra for how we eliminate the parameter, and then we're going to find a few shortcuts that might be helpful for us when we get to Calc 2. Okay? All right, my friends, I'll see you back here for the third video.